In the Solve It, you described how one line could be shifted to result in a second line. You can use a similar method to graph absolute value functions. An absolute value function has a V-shaped graph that opens up or down. The parent function for the family of absolute value functions is y equals the absolute value of x. Here's an example of an absolute value function graphed. Notice the x-intercept labeled, where it crosses the x-axis on the left-hand side. The vertex, the bottom of the angle or of the absolute value function. Sometimes it can be the top of the absolute value function if we have a downward opening v. The y-intercept, where the line crosses the y-axis. And then the second x-intercept, where it crosses it too. Now, we also have a new word here, branch. A branch, it's almost like a ray if we were to consider the absolute value function to be an angle, but we have two branches in an absolute value function. A translation is a shift of a graph horizontally, vertically, or both. The result is a graph of the same size and shape, but in a different position. Problem 1, describing translations. Below are the graphs of y equals the absolute value of x on the left and y equals the absolute value of x minus 2 on the right. How are the graphs related? Well, consider the graphs carefully, looking for any differences and trying to relate those back to the functions themselves. The graphs have the same shape. Notice each point on y equals the absolute value of x minus 2, the graph on the right, is 2 units lower than the corresponding point on y equals the absolute value of x, the graph on the left. The graph of y equals the absolute value of x minus 2 is the graph of y equals the absolute value of x translated down 2 units. Your turn. Part A. How is the graph at the right related to the graph of y equals the absolute value of x? And part B, a reasoning item. What are the domain and range of each function in problem 1?